Welcome back. During last lecture we were talking about the internal and external factors, and we started talking about the lithology part. I will just briefly go back that the internal factors and the external factors, which are extremely important to understand, because these factors results into the landslide in most of the regions, like slope angle, lithology, groundwater, climate, vegetation, geological structures, and external factors like earthquakes, volcanic activities, and human influence. So, one by one we will see a few of them. Like for example, the internal causes, we take the lithology factors. Okay. So, influence of slope, it provides very favorable conditions for landslides. Steeper slopes are definitely prone for slippage of land, and it is common that most of the material, as we were talking in the initial slides, that slope angle is extremely important, and that what we call the critical angle of repose. So, each material or different material on the earth surface has different critical angle. For example, for unconsolidated sediments, it is around 30 degrees. So, it will remain stable until you have 30 degree of slope, but if you increase the slope, it will slip down. Then coming to the massive rocks, it has more angle of repose, like 60 to 90 degrees for partially jointed rocks, and for massive rocks it is around 90 degrees. Further, the another factor which is responsible for the landslides or the slippage of the landmass, groundwater and associated water. Now, this is one of the main factor responsible for the slippage, because this reduces shear strength of the material. So, suppose if you have an harder rock sitting on the surface, but subsurface or the it is on the below it, you have some softer rocks. Okay, because you will not have the complete succession comprised of massive rocks. Okay, or massive material or hard material. You have softer and harder, softer and harder succession you will see. So, suppose you have a clay and clay bed or shale. This we have discussed when we were talking about the different type of rocks in the previous course, the part 1. Now, suppose you have a clay bed, then when the water percolates through some of the fractures or joints, the clay beds becomes very plastic. Okay, and this will act as a slippery base. So, even though you are having a very hard rock sitting on the surface, but subsurface material is softer, it may result into the slip. Then coming to the water, as we all know that water is the most powerful solvent, which not only causes decomposition of the minerals, because it has a capability of altering the minerals also, but also leaches out the soluble matter of the rock and reduces the strength. This is what we are talking about, the reducing the shear strength of the material. So, water is everywhere, it creates problems on the slopes. Then the lithology part. Okay, as we understand that most of the rocks will have different minerals, and if suppose those rocks are comprised of the minerals like montmorillonite or bentonite. Okay, so this is one of the examples which we are taking up here, or they comprise mica, calcite, gypsum, etc. These minerals are prone to landslides. Okay, because they will absorb water and they will reduce the shear strength of the material. And as we know that these minerals are commonly seen in most of the rocks. Okay, so that those minerals are prone to the landslides. Okay, and mainly the minerals which are rich in clay, these are or the rocks which are rich in clay will result into the problems. Okay, geological structures is also another important part to be understood, and if you are having the the sedimentary rocks which are rich in bedding planes, joints, and they are faulted or fractured or having the shear zones. Okay. These are the weak planes which will trigger the landslides and resulting into the instability of the slope. Okay. So, in short, we are taking into consideration the lithology part, we are taking into consideration the geological structures to understand that which are the most triggering factors for this landslides and all that. Now, just to show this, I hope we have discussed this in the first part. The clay has a capability, for example, the clay minerals like montmorillonite and all that, they have the capability of absorbing water. Okay. So, they will absorb water, and since they have the sheet like cleavage or the structures, okay, then this will enhance the capability of absorbing water between the sheet planes, okay, making the wet clay weaker, slippery and easy to mold. So, if you are having more amount of water percolated below the surface, and if you are having a clay bed, then you may face the landslip, okay, because of this. Now, role of climate fluctuations are seasonal and have direct effect on the erosion and weathering of the material on the slope. So, for example, role of material, if we take vegetation plays important role in slope stability. Thick vegetation cover protects the slope from direct impact of rainwater, because if you are having the barren area or barren land, you may have the erosion will be very fast, but to some extent the vegetation cover will protect the slope surface. Root system provides indirect cohesion to the slope material. So, it will hold the roots will hold the material on the slope, and as you might have seen in many places in the hill slopes, you will see that to have the slope stability, a lot of vegetation has been put. Okay. But one should remember that you should not put very huge trees, okay, on the slope, because that will increase again the overburden over the slopes. Thick vegetation add extra weight, that is what I was talking about, that if you have an thick vegetation, that will add an extra weight to the slope, can also trigger shallow soil to slip on the steeper slopes. Deforestation in the uplands result into more erosion during rainy season, and that can reduce the shear strength of the superficial material, which can result into landslide. Coming to the external factors, as we were talking about, that one is the human influence. If you are doing the undercutting along the hill slopes and for laying roads or rail tracks, can result into instability of the upper part of the slope and can result into landslip. Most common is the vibrations result due to earthquake, blasting or volcanic eruptions, that can result into your landslides also. And volcanic eruptions, it has been seen that this can result into the lahar flows also, and can also trigger landslide close to the coastal areas. Even the earthquakes can trigger landslide in the hilly tracts, not only along the on the continent part, but along the coastal regions also. Earthquake often initiate mass failures on larger scale. Example, 1897 Assam earthquake produced very huge landslide, okay, which was one of the largest one. These are some examples from Armenia, 1988. The magnitude was not so large, but moderate magnitude resulted into the landslide. Another, this one is from Colombia, mud flow, but this was what we have discussed, the lahar flow, because this was triggered by the volcanic eruptions, and because of volcanic eruption melting the snow caps on the cone. So that is one of the reasons why we can say that volcanic eruptions can also trigger landslides. Then coming to the other part, this is one example which has been given again from the same area, Colombia. So the picture which shows on the left is before, and this was after. Okay, so the whole area was been swept away because of the lahar flow, which was triggered in 1985 in Colombia, and this was because of the volcanic eruption and melting of snow on the volcanic cone. This is the landslide from 1991 Uttarkashi earthquake in India. This was from 2005 Muzaffarabad earthquake. The satellite picture shows the major landslide which occurred over here, and it also choked to some extent the river valley here. Okay. So this type of landslide can also result into the natural damming in the hilly tracts. Okay. This is the same photograph, aerial photograph, which shows the landslide due to 2005 Muzaffarabad earthquake. Again the same photograph showing the landslide over here. Now this is another very good example which talks about that even if you are having the harder material or stiffer material sitting on the surface, but having the softer one below can result into landslide. Now this area had sand and gravel succession overlying marine clay. So what people they had the houses sitting on the top of this layer here, which is comprised of sand and gravel, and below that they had a stiff clay bed, and further down they had a sensitive clay bed. Okay. Now this sensitive clay bed was extremely dangerous and which slipped at the time of the Alaskan earthquake of 1964. So as we were discussing that if we are having the steep or harder material sitting on the surface, we are rest assured that nothing will happen. Okay. Likewise in this case here. But if you are not having the understanding of the subsurface material, what is sitting below which may slip, okay, that is extremely dangerous. So this material, the upper clay layers were relatively stiff, but the lower layer consisted of sensitive clay. The slide moved about 110 meters towards the ocean, breaking up into series of blocks, and those blocks rotated actually. Okay. So they had a massive landslide or landslip, okay, which resulted into the rotational sliding. So this is like the example which can be taken into consideration, that it is extremely important to know that what exactly is sitting deeper at the deeper part of the succession, not only in the upper layers. Okay. Another example of the landslide. So we are never bothered about that we are sitting very close to the hill slope, okay, and we keep on constructing our houses close to that, but the landslides can result into this. So this whole area got affected during the landslide which was triggered in Salvador, okay, in 2001 earthquake. Now classification of landslide further, if we take, okay, most widely used classification was been given by Vernes in 1978, okay, and the classification of the landslide was on the basis of the type of movements and the type of material involved in mass movements, okay, because we have like coarser material, we have finer materials. Okay. So landslides, or we can generally call that as a mass movement, we can classify as faults, slides and earth flows, okay. And this all has this will have coarser material, this will have the combination of coarser and finers, and this will have mostly the finest one. Okay. And then coming to the land subsidence. Okay. Now, slides, as we call, again it may be faster, it may be slow also. Okay. So, slides, if a mass of the earth moves along a definite plane or surface, the failure is termed as landslide. Movement may be along one or multiple planes, where during movement the moving mass may experience considerable deformation. So, this deformation is nothing to do with the tectonic deformation, but because of the slip it will experience some deformation, internal deformation. So, this is nothing to do with the tectonic deformation we are talking about, but the deformation may be very much similar to what we see in the tectonic deformation. So, the most common slide occurs in clay soil where slip plane is like a spoon, okay, shape, and they are referred as rotational slides. You will be able to see the slip plane at in some of the landslides of this type. Okay. So, rotational slides, these are again, this is an example of the rotational slide where you can see this feature is like spoon shape, okay, and the portion which has moved down here, this one, will experience or will have the deformation within that, because it has moved down, and because of the movement it will have some deformation. We will see that in coming slide, okay, how where the deformation looks like. Okay. So, results from the tensional, this type of deformation or sorry the rotational landslide will result from the tensional scars in the upper part of the slope common after earthquakes. Okay. So, you have, for example, some tensional scars on the surface here, or maybe the extensional cracks which have developed over the time on the slope here. So, at the time of an earthquake or ground shaking, this may result into the landslide, or if you are having the groundwater going in, okay, then also it can result into the landslip. So, it is extremely important that such slopes are monitored constantly to know that whether this area will slip or not. Okay. So, rotational slides, okay. In rotational slide, material moves suddenly along a curvilinear plane. Okay. So, plane will be curvilinear here, and if you see this part here, this part has moved along in multiple planes, and then this area is having like bulge like here. Okay. So, this portion will experience some sort of a deformation, very much similar to the folding part. Okay. So, this will have folding within it. Okay. So, these are termed as slumps, okay, and earth slumps are defined as non-bedrock deposits that moves downward on a rotational failure plane. So, here if you see from the side view, you will be able to see that this is one crack, there is another one, there is another one here, and so on. So, it is having the extensional cracks, and the slope along which the movement occurred are all this curvilinear planes here. Okay. So, it has occurred along the multiple curvilinear planes. Again, similar example where you can see clearly the scar and multiple extensional cracks here. Another example of the same area. Rotational slide again. So, what you will be able to see is that you will have the crown with cracks, which is given here. So, you will have the extensional cracks on the upper part, then you will be having the main scar, that what you see like in spoon here. This one is the main scar here, which you can see this part, and then you are having related slide blocks. Okay. So, these are the blocks which have moved along with the same plane, and this is the main plane actually. See, this is the main plane, and then you are having minor scarps, which are minor scarps as marked by this one. So, this you are having the scarps here, which you were able to see over here. Okay. These are all the minor scarps, okay. And you may be having the external cracks on the top, and this is the main scar. Then you are having the transverse tensional cracks, okay, which are seen over here at the bed, and this lobe or the toe part will have the deformation, will experience the deformation. Similar example which has been shown, that on the surface you may see multiple scarps here, okay, and then you are having a lobe here. But this movement, in if you see, you will be able to see something like steps like this. Okay, these are all connected with the main radial plane, and then you are having another minor one. Okay, so you are having multiple planes along which this movement has occurred. Now, during this type of slide, okay, you may have the landslide comprised of unconsolidated material, which we termed as an debris flow. So, it may have the gravels and along with the sandy matrix, or may have gravels or along with the sandy or clay material. Okay. You may have the rock slide or the rock fall also, which will comprise the larger rocks. They are common along the steep slopes, along steep road cuttings, as has been shown in this figure A, okay, or along the river banks also. Now, this is an example from India, near Chandigarh, where we looked at the landslide which occurred along an hidden slip plane, and we identified this as a rotational landslide. Okay. Now, if you carefully see, you are having a river bank here. The river is flowing, this in Gaggar river, which flows in this direction down. This is a river channel. If you see this part here, there is a river channel here, and then this you are having the huge cliff, because it is cutting the Shivaliks, the younger succession of the Himalaya. Now, if you carefully look at what we were able to notice, that nothing was been seen here much. Okay, few cracks like this. Okay, but this portion, if you carefully see, I'll show the close up. Okay, of this one. This is slightly warped. Okay, so you have an elevation change here. Okay. So this was very interesting to understand that what exactly happened here. People talked about that this was an surface rupture because of the 2001 Bhuj earthquake. So it was a bit impossible for us to understand that why so far from which is sitting almost like more than 1000 kilometers, the surface rupture will occur here. Okay. Then we visited the site and we looked at what exactly happened. Okay. Now, this is the example of the warped lobe or the toe part of the landslide. Okay. So, you can see this area here. So, this portion moved over the surface. Another close up of that. Okay. So, this is the lobe of the the landslide. Okay. So, if you see, if I put the cross section, then what I will be able to see is that this was initially this flat surface here, the river bed or the floodplain area. Then because of the push from here along the slope, the material came down and then this moved over the top of this. Okay. Or you can say that this was been pushed and this was been. So, if I see the section, I will be able to see something like this. Okay. So, this area it moved. Okay. So, this will definitely show folding here. So, it will show the internal deformation. So, this was moved along the plane. This is the plane coming from the surface, from the steeper part. Now, the interesting part which we were worried about here was that this similar type of slip can occur in future also here. Okay. And since this area has been already like occupied, I am unable to show the, but there are some small white blocks which have been put here. So, what does this indicate is that this area is already marked or plotted for new houses coming up here. Okay. So, they have the plotting has been done and this area will be quickly occupied and might have been occupied by the residential colony here. Okay. So, this type of slip will occur again in future also and will result into the severe damage to those houses. Okay. So, one has to be careful about choosing the locations for construction. Now, what we did was we again we understood that this is a landslide, but we wanted to know that whether it shows some extensional cracks on the surface on the hilly part or not. So, we visited on the top and we found that it was. So, these are the scars here. This is one scar here and there is another one here, and then we have the extensional cracks which are developed on surface. So, this extension on the hilly portion or the steeper part resulted into the movement of the mass along the rotational or the curvilinear plane. Okay. So, this we classified as a rotational slide which we observed close to Chandigarh. Now, translational slides. Okay. There are those we were talking about, the rotationals one. These are translational slides. So, movement parallel to the planes of weakness and occasionally parallel to the slope. So, on the slope mostly what we see is that if suppose you are having a stratified rock, okay, and we are having the bedding planes, these are all the bedding planes which are being shown here. Okay. Now, they are dipping towards the along the slope. Okay. So, these are the weak planes which may result into the slip, okay, in future. So, occurs in inclined stratified deposits, okay, bedding planes. Then this is another example of, again we are having shale and limestone, okay, and this type of landslip, we term this as a rock spread, okay, are defined as blocks or the slabs of bedrocks. Okay. So, you are having a bedrock here and you are having in, of course, in shale again, and they both are limestone and shale are sedimentary rocks, but shale is again they comprised of finer material. Okay. So, this may result into the lateral spreading. Okay. So, lateral spreading may develop in finer unconsolidated sediments like clay, silt and sand. It is mainly due to increase in pore water pressure at relatively shallow depth. Okay. And increase in pore water pressure can be resulted because of ground shaking also, that is because of the seismic events. Commonly seen examples during earthquake, this is an example of lateral spread during 2001 Bhuj earthquake which happened, and if you see this in the ground, it is almost flat. Okay. So, the slope is very gentle, but even then this phenomena occurred because of the very soft material sitting below the sandy units. Okay. So, this is an agricultural field which had a very gentle slope of hardly 2 degrees. Okay. As another example photograph from 2001 Bhuj earthquake, lateral spread. So, slope is very gentle. If you can see this here, the car standing here and the person standing here, slope is very gentle, then also it occurred. Okay. Because it had very soft material sitting below the sandy units on the surface. Ponding due to landslide, as I was talking about, that if you are having the landslide close to the river valley, it may choke or block the river channel and will result into the natural damming or natural dam. Okay. And this is very commonly seen in Himalayan region, where scientists have identified that the lake deposits, okay, in many locations which are sitting but at greater height, but they right now they do not have any lakes which exist there. Okay. So, this indicates that in past also the landslide close to the channels or the valleys blocked the rivers, resulting into formation of artificial natural dams, and which when breaches will result into the flooding in that area. Okay. So, this is an example of again a small lake which has been developed because of the choking up of the channel here. Okay. So, this is a stream here which goes, but this got choked up because of the landslide. So, rotational slide, as we were talking about, another example from Himalayas close to near to Dehradun. Now, this is again I would like to explain here that in most of the regions in the hilly terrain, the roads are been laid across the river channel on the river bed. Okay. They will not do the good foundations and all that, they will not put, and they will just lay down the roads on the top of the river beds. And what will happen over the time after each floods, that you will find that this is eroded away and slowly it will go off. Okay. This is one of the good example which we observed in Himalayas, which again close to the Dehradun area, and the backdrop, if you see here, you are having some whitish patches. These are nothing but the perennial landslide, I will say. The landslide is active here, and this is close to the main boundary thrust. Okay. And this area is the landslides which has been known as Kala landslide here. So, this bridge was constructed long back, maybe 40 years back, and we will see the close up of this. So, the problem was that because the shared material is available here, because of the ongoing deformation of the Indian plate, between the Indian plate and Eurasian plate, whenever there is a rain, this all material will be flowed down into the channel, and this will block the river bed here. Okay. Or this material will fill up the river bed and does not allow the water to flow under the bridge, but it will flow over it. Okay. So, over the time what they did was they constructed this photograph we were showing, we were looking this from the downstream side, this is the upstream, and this is your downstream. So, this we are viewing from here, the next photograph we are viewing from this side. Okay. So, just keep in mind that one. What they did was that they constructed the retaining wall. Okay. So, this whitish patch which you see here is your wall, which was constructed again on the river bed, but to protect the bridge here. Okay. So, that you have through and through passage of water during the rainy season or heavy rains. Okay. Now, what happened was quite interesting. Okay. So, in 2001-2 we took the field trip here. Our B.Tech batch is sitting on the retaining wall here, which was been created. Again, the photograph is from, we are looking from downstream to upstream. Still you can see some scars here of the landslide, Cholera landslide. So, we found that this huge wall was been constructed, and to protect the material which is coming down during the heavy rains and choking up the river here, okay, or choking up the river bed, and damaging, probably it will damage the bridge also. So, this was in 2001 and 2 batch which we took. What happened next? Okay, you can see this one here. So, what was the problem here? Again the same. Okay, the retaining wall was been constructed on the river bed. So, there was a percolation of water underneath. So, water flowed through this, okay, and it removed the material or the wall from the base. Still the top remained more or less intact here, but this moved. Okay. So, this is another example what we can take of the landslide. Okay. So, the top remains intact, but the subsurface material moved. Please look at this video, which shows that in 7 to 8 days the slip occurred along this slope. Okay. And you can see the material coming on the road here, and this going down. Okay. Now, coming to this part, this is an example from the Himalaya, where okay, we can continue in the next lecture. Thank you so much.